Okay, so here I am at a waterfall in Hong Kong, and this one is by taxi, well, the tough of the Mount Davis member. So if we look close up at the actual rock, you can see this is actually quite withered, but you have a lot of feldspar, small crystals, about 1 to 2 millimeters in diameter. And this surface is actually quite weathered. It's quite a nice waterfall. So you can see the actual fractures in the actual rock where it's so this is naturally occurring. Probably would have caused when it was actually cooling, because even though this is a tough type of rock, it would have contracted as it was actually cooling. And once again, so you need to actually break it open to find any real geology. So the weathered stuff that we're looking at, it's not really going to tell us much. Anyway, so this is like a geography course. So as we know, geography is affected by geology. So now we are looking at a stream, and this stream is actually close to the source. So here we have one peak, and over that peak we have a lot higher peaks, and this stream continues up probably 2 to 3 kilometers upstream. But in Hong Kong we haven't had rain for like 30 days since I've been here. It's a dry season, but there's still quite a lot of water in the river. So there has to be a source, like a type of aquifer that's holding the water in, that's releasing it. And I wouldn't be surprised if it's these fractures here that you see that they're actually throughout the rock, and they can actually hold quite a lot of water. So as you should know, with gravity, the water wants to come from upstream and wants to head all the way down to the coast, and that's where this stream comes in. So we have the slopes of the hills, and the slopes of the hills are also feeding the water into the stream. So the water's coming down from the slopes, because these slopes, they do have the fractured rock. They do contain a lot of also groundwater, the aquifer water, and that's why the plants are still green, even though for 30 days it hasn't rained. There must be still a lot of water in this ground, because Hong Kong does get a lot of rain as well. So a lot of rain, the rock can hold a lot of water. So unlike Australia, in which the aquifers, Australia's pretty dry. So we can't see any of the original rock, which is a pity. Maybe I'll go upstream to the little Hawaii waterfalls. I can't remember what this waterfall is actually called, but this is actually the better one, because you have a sequence of flows and rapids. So I wouldn't actually try and cross that. You probably get swept all the way downstream. But there is a bridge that you can cross, which is quite nice. So this is Oitaxic welded tuff. Has a lot of has Fiammia in it. I don't see any in this outcrop. It's usually a fine crystalline or glassy quartz and feldspar with crystals, probably 1 to 2 millimeters, but all the way up to like those 5 to 10 millimeters of every quartz of feldspar. Most of them I've seen have been probably orthoclase feldspars, so the potassium feldspars, and Some locations you can get big pumice that have been embedded in the actual rock. So this, in Australia we call this Ignimbrite. Ignimbrite. It's a very hard rock, very hard to erode, and that's why you can see the nature of it is actually blocky. So it breaks off pretty like a 40-degree angle. Not 40 degree, 45-degree angle. Some places, and a lot of places is 90 degrees, so you got one like that. So that's how that breaks off. It's pretty much like a glass in that matrix. Some of it's conchoidal, but I don't see any here. But when it gets weathered, it is rounded. That's quite nice. And this affects the actual stream, because the stream would need to actually come down into the fractures. So these fractures here are what the stream eats first. You can see that fracture just there. So that will just keep on enlarging and eating away at the side. Now the top of it's still been eaten away, but that's a lot harder. It's easier to go through the side. You have a lot greater surface area than the actual flat bed of the actual creek. And it's going to eat until it finally turns into something like this. So this has been eaten away quite a lot, but now this rock is 162 million years old. It's probably been eroding for pretty much that time period, because there's not much rock that's younger than 50 million years in Hong Kong. So only the fluvial stuff, so the stuff that's been eroded here is pretty much the younger stuff. And eventually it's just going to eat down until we get to the level down there, then we get to the level down there. So this stream could potentially be 50, 100 million years. We don't know how old the stream is, because this could have been an actual mountain range. Okay, so this could have actually been a large mountain range, and this stream probably couldn't have been here. Or maybe the stream, flowed over the other direction, so in the opposite direction. So we're not too sure, because we don't have any evidence. All of that would have been eroded by now, especially, beautiful blue butterfly. I wanted to get a photo of that. Yeah, I like butterflies, so what? And these streams will actually change directions, depending on the landscape at the time. So I hope this helps you a bit with stream geology and how it interacts with the actual rock type. And we'll go upstream and we'll see the other waterfall. Looks like there's a fracture feature there. It's probably been infilled. That's a bit strange. Never seen that in these formations. So here I am at Little Hawaii Falls. And this is the same type of rock. It's Ignimbrite. And as you can see, it's also well weathered. Obviously, people do like to actually walk on this rock. But if you go close up, you can still see that this has fine feldspar crystals in it. Probably there's a fine quartz, but they're a bit hard to tell when it's weathered like this. So this should also be autoxic in weathering profile. It's usually a bit hard to see when it's fresh. Don't see any here. And also should have Fiame. And sometimes it has pyroclast. So I think there is a dam up here, so that's probably what's holding the water in. That's why the flows are still going. But if you look at the rock here, so there seems to be a line pretty much going like that way. It's obviously, you can see over there, that seems to be up a lot of vesicles. So this seems to have been quite compacted. This doesn't seem to have been compacted as much, although it still has a glassy nature. And you can see it has a lot of vesicles in it, but the vesicles so this is the plane of compaction. So obviously the vesicles are being compacted. So this is probably pumice, a lot of it. It's being compacted, but not compacted fully. And obviously the compaction is probably coming that way, and this is the bottom. So that's why you have them all parallel. So that is very interesting. I haven't seen this before in any of these formations. So you can see what I mean. So the actual plane of compaction is it's about 45 degrees. So it's a dip, the actual formation. And here we have some more. So obviously this is, do I see any large fiamma or pyroclasts or anything like that? No. You can see where these are easily eroded as well, because it gives more surface area. And up here, I don't see that much compaction in this rock at all. Well, up there I do. Okay, so there are two other formations around here. So we've got, which way? Yeah, that way. So that way is up. It's about southeast or somewhere. So that's the Kellern granite, and this Davis formation lies on the Kellern granite. So obviously the Kellern granite is part of the actual main volcanic plug somewhere. So it's probably the base of the volcano. And this is deposited probably on the side. I'm just guessing here. I don't know. I don't think anyone knows really. And if we walk that way, we have the Chi-Ku-Wan formation, which is another tuff. So another Ignimbrite, probably from another volcano. I'm not too sure. I think the mineralogy is a bit different. So you got the granite that grades into the Ignimbrite, which is the flank of the volcano. And then you got another probably volcano over there. And these are all about 142 million years old, so they're all pretty much the same age. That's why the granite and the Ignimbrite here probably come from the same formation. So, but what you need to do is check the mineralogy. Mineralogy. Sorry, my English is a bit stuck. Of the two formations. So the actual feldspar crystals probably formed before it actually came out as a pyroclastic flow or an ash fall. looking at Turnquang Island. So the old village is just down the bottom, and the new development is pretty much all around. Hang Hale's just over there. Obviously there's this large block, eventually that's going to fall down. And I see there's like autoxic patch in there. So I see some of it. But a lot of it seems to be massive. So this is just the actual pumice that's been crushed as well as the glass. Nice formation. So here we have a man-made feature, dam. It actually makes the waterfall a lot nicer. So here we have another fall up there. Pretty much right there is what's left of another dam that they've made before. But as you can see, Ignimbrite's pretty massive. Ooh, dragonfly, like dragonfly.